I'm Dave Baring, Technical Director here at TriStar, and welcome to another Tech Talk. Today is another of our quadrant series, and we're going to be talking about the Ketron product. Ketron is Quadrant's trade name for their PEEK line, which is polyether ether ketone. And they offer a variety of materials, and we're going to be talking about all of those, and specifically talk about the HPV material, which is their bearing grade product. PEEK is obviously a very popular material today in the world of engineering and plastics, especially in the high performance materials. It's one of the most cost effective, one of the most diverse materials, and you'll see here as we go through the presentation how diverse it is in terms of application. But again, looking at our triangle, you can see here that PEEK is in the upper echelon of the materials. It's up along with the PPS and the Torlons and the polyimides. The operating temperature, again, is the driving factor here, and PEEK has a continuous operating temperature of 485 degrees with some new variations that will take it a little bit higher than that in terms of continuous operating. So as we talk about the PEEKs, keep in mind that this is one of the higher grades of materials. When we start looking at PEEK and Torlon and some of the other materials that we've talked about in the past, realize that we're talking about the now the Cadillacs and the Lincolns of the plastics world. So price is relative. But let's take a look at some of the Ketron compounds. First of all, the Ketron 1000 is the Quadrant unfilled PEEK. It's the virgin material. This is an FDA compliant material. It also meets USP Class 6 compliancy now. Quadrant does offer an entire line of life science grade materials, and feel free to visit their website or contact TriStar regarding these types of applications, because there is a whole family of Quadrant materials that are available now for specific life science applications. The unfilled PEEK is becoming very predominant in the implantable world. Everything from spinal surgery to brain surgery, where they're using PEEK for screws to hold skull plates in, and some very unique applications. And the PEEK is just an extraordinarily strong material, and that's why they're going to it. And now that it has its USP 6 clearance, it's certainly an up-and-comer as a polymer implantable material. But the unfilled material also has some other unique applications. PEEK is a very hard material naturally, and so you wouldn't think of using it sometimes as a seal, but the unfilled material is a very ductile material, and so in terms of its pliability and its ability to conform, it's a very strong candidate for some types of seal rings, specifically piston type seals, and we'll talk some more about that in some application reviews here. But seal rings, if you've got applications in pumps where you need that chemical inertness, the PEEK is obviously a great candidate for that application as well. So again, unfilled, very ductile, elongation is up around 25-26%, so it gives you a material that's very compliant to all types of different conditions that you may use it as far as seal rings. The GF30 is Quadrant's 30% glass-filled material. This is primarily a structural material. It's really something that if you're looking for high strength, low thermal expansion, very high flex modulus, this is the material that you'd want to take a look at. It doesn't really have any bearing properties at all. It really is more for structural integrity or possibly even dielectric applications. The glass-filled PEEK is a very sound dielectric material. But strength and stiffness, and of course high temperature stability. It's got a very low thermal expansion rate, and so if you're looking for structural with great stability in terms of thermal conditions or even physical properties, PEEK, being one of the higher end materials, will maintain its physical strength across a much broader temperature range. So the glass filled is, again, if you're looking for strength, stability, low thermal expansion, stiffness, these are all the things that you get out of the glass filled. The next one is the CA30, which is the 30% carbon filled. Now this is a carbon fiber, so it's going to be extremely strong, extremely stiff. So in applications where you've got high compressive conditions, or if you've got an application where you want very low thermal expansion, the carbon material is very good. The other nice thing about the carbon fiber is that it's also a good heat transfer material. We have used this product, even though it's not specifically a bearing grade material, it's a very good bearing grade material. And we use it a lot if their application requires high resistance to compression and good thermal transfer properties. The carbon fiber does a nice job of pulling heat away from that dynamic surface. It's a great application where you need the low thermal expansion and that conductivity. And then finally the Ketron HPV, which is really a highlight material because for us at TriStar we do a lot of work with bearings, and so this product is one that comes into play an awful lot. It has 3 different fillers, and each one has its own reason for existence. Some for low friction, some for break-in media, also for physical strength. So if you're looking for that blend of lubrication, high strength, extraordinary PVs, then the HPV is a very good candidate for bearing applications. Now, some of the primary characteristics of PEEK. High continuous operating temperature, 480, 485 is a fairly common number. In certain conditions, you can push that a little bit higher. As I mentioned before, there are some new compounds that are out now that allow for even higher operating temperatures in the PEEK family, but those are more of a custom product, so give us a call at TriStar and talk to us about that if you have a situation where you want to use the PEEK for its strength properties or its chemical inertness, but you need a little extra oomph as far as temperature. We do have some options for you. But anyway, high continuous operating, again, 480, 485 is what we kind of design around. Excellent chemical and hydrolysis resistance. You know, PEEK has very similar chemical resistance to PTFE. And so that makes it very unique. You've got that chemical resistance, but you've got a much stronger material in so many ways. Has a very low moisture absorption. Very low moisture absorption. It also works very well in steam. You see a lot of PEEK being used in steam valves for seats and stem seals and stem bushings. High physical strength at elevated temperatures. Again, as I mentioned earlier, because this is one of the high performance materials, the common thread with all those materials is that they maintain their physical properties even at the elevated temperatures. So you don't see a dramatic drop-off early in its temperature band. You can push it very close to its continuous operating before you see that big drop. Excellent wear properties with the CA30 and the HPV. Because of the additives and also just the inherent nature of PEEK, they have very, very good wear properties for dynamic bearing applications. Good machinability. PEEKs are not difficult to machine. They don't chip as easily as some of the other materials like Torlon and the polyimides and PBI tend to be a little chippy. So these do machine very well. You just have to follow the directions and you'll do fine with it. It's available in rod, sheet, and tube. molded tube. Now, something I want to point out is the production techniques. If you look in the quadrant literature, you'll see that they mention various types of processes. They have compression molded and they have extruded. There's also injection molded. You can process PEEK with all three techniques. But what I would warn you on, and we've run into this with some customers, is that many times a customer will go on to a website and take the numbers off the website and use those for their design. And that's especially difficult if you go to Victrex, for instance, who manufactures, is one of the manufacturers of the PEEK compound. And the information that they use in their technical data sheets is really relative to test samples on the resin. It doesn't necessarily translate when it comes to the final processing technique. There are differences. You will find differences between extruded material and compression material and injection molded material. And we have actually done a spreadsheet that we're happy to share with you that talks about those very specific differences, because it can be a problem. We've had cases where customers have used too high of a number, and when it came down to actually making parts, the process for the material was different from the process they designed the specs around. So be a little careful there. Just a little word of warning when it comes to the PEEK material. Let's look at a couple of applications. First of all, on the Ketron 1000, again, this is the virgin material, the unfilled material. And one of the advantages, again, being an FDA compliant material, is that it's a very good material for food processing machines. This particular application was kind of unique in that it's a combination vending machine where it's actually producing ice cream, and in the wintertime it can also produce hot chocolate. So you have a material that has to withstand a couple of very different conditions, but it also has to be able to withstand clean down solutions. It also has to be very strong. In this particular case, you can see this is a valve that's being used to allow flow of the product through the machine. So in this case, we used an unfilled PEEK to replace the stainless steel. Obviously, the stainless was very expensive. It was heavy. When it comes to clean in place, a lot of these components have to be removed from the machine and cleaned with the cleaning solutions. Others can be left in the machine, but in this case we were able to save weight, we were able to save cost. Even though PEEK is an expensive material, it's not as expensive as stainless when it all comes down to the end of machining and everything else. But the reason for using the material, it's physiologically inert. It's compliant to FDA, USDA. Good chemical and hydrolysis resistance that comes into play here because of the clean down. Good dimensional stability. While this part didn't have real tight tolerances, it was enough to where if you use some of the more traditional engineering plastics, you probably would not have been able to hold the tolerances. Again, because of its machinability, as you can see from the part, there are some broached grooves on the ID. That's not easy to do with a lot of plastics because of the ductility issues. But with the Ketron 1000, it was easy to do and left very clean, fine machine components. And then finally, the temperature resistance. Again, because we were going from a low temperature extreme to a high temperature extreme, and the material was stable in both conditions. Another application for the Ketron 1000, again, as I mentioned earlier on, because of the ductility, the compliancy of the material, this application was kind of a unique one in terms of its need to comply with fairly uneven, rough bore on this hydraulic motor. And this is on a ship winch. So the actual seal strips, which are about 3/8 by 11 inches long, there's several of them on each one of these motors, has to be able to conform to that bore and maintain good positive sealing capacity. So in this case, we were looking for wear resistance. We couldn't go to some of the filled materials because of the ductility need. So we went with the PEEK just because it inherently has pretty good wear resistance, even without additives. Good chemical resistance. In this case, it was hydraulic oil. But you never know what's going to happen out in the field, especially on board a ship. There could be a variety of different hydraulic fluids that are used. Good dimensional stability. Again, being a seal, you need to be able to control tolerances fairly closely, and you can do that with the Ketron materials. Next application is looking at the carbon filled, the CA30. This particular application is part of a mechanism that's used to hold bones in place after an extremely serious break. The reason for going to the PEEK is that it's very lightweight. It's less expensive than going to very sophisticated carbon fiber materials. This part could be machined out of rod, and it could be machined to any kind of configuration that was necessary for this particular appliance. But here was a case where they needed good stiffness and strength. Obviously, you had the weight of a human being walking. It had to obviously maintain its stiffness so that you don't have any failure of the bone while it's going through the healing process. Good hydrolysis resistance. You don't want a material that's going to be swelling for a number of different reasons. Good dimensional stability. Again, we're looking at holding tolerances here. And then because it's a low density material, it's very, very lightweight. And we humans don't like to carry around any more load than we have to on our body, so it was just a natural fit for this orthopedic appliance. Another application for the Ketron is in the HPV material. Now this application is one of two very similar applications, both in terms of autoclave components. This particular picture that you see here is a trailer that carries uncured fiber cement, and these are can be in any form, in the form of boards or panels, whatever. But they have to take these uncured parts and put them into an autoclave oven and cook them up to 395 degrees for 2 to 3 hours. And then they're brought back down to a lower temperature for several hours and then pull them back out of the ovens. Now in this case, the load on these little wheels was about 4,400 pounds, and that was on each bushing. And the bushings were 2 by 2.5 by 1 3/4. What they had used before was a simple bronze bushing. The problem was that bronze needs to be lubricated. And when you're going through these temperature extremes, the lubrication just doesn't hold up very long. And in this case, especially where it's unsealed, the lube would leak out, and basically the effectiveness of that bushing was lost. So in this case, with the HPV, it's self-lubricating, has good hydrolysis resistance. The load capacity was no problem at all for this HPV material. Had low friction. They didn't have to lubricate it anymore. And of course the temperature resistance and the inherent value of that, the close tolerances and everything, were very applicable in this particular design. Now we have another application I don't have a picture of, but this is a very similar trailer application, but it's a little bit more unique in that the trailer was actually carrying a rocket body. And this was a trailer that was used to carry sections of the rocket bodies for missile systems that are used to launch satellites. So they're made in very large sections, usually 30 to 40 foot long. And so the trailers have multiple number of wheels, each wheel carrying between 2,000 and 3,000 pounds. And historically, what our customer was using was a sealed ball bearing. And these were fairly large ball bearings because being a space